with that being said, ooh, how many valence electrons does Krypton have if its electron configuration is that? So Krypton, let's look at it real quick. Periodic table. Surprisingly, it actually follows the same rules when you want to actually do it from the previous noble gas. So the question is asking how many valence electrons does Krypton have? Okay, and they're nice as gives an orbital notation, but if we solve this, actually it'd just be started AR, because that's the previous noble gas, and we go through all of them. So we have 4s2, and then remember here when we do the D level, it's 1 minus, so it'll be 3d10, so it's completely filled up, and then we're back to the 4s, 4p6. So if we reorganize this, actually it would be AR, whoops, 3d10, 4s2, 4p6. And now it's asking us how many valence electrons does Krypton have. Okay, so actually we use this here to find out. Okay, and there's actually a formula. The formula to find out how many electrons are in that orbital is dependent on the, remember how we had the S, the L, the ML, and MS? Is dependent on the L, because the L tells you, remember, for, I like to just change this to a different color, bear with me. So remember how if it's an S orbital, oh, I knew it, I know I had it wrong, it's N, not S. N is the number as in the orbital is on. Okay, so if we went back over here, just in case there's any confusion, N, I did have N, I don't know why I put S. I always confuse those two letters for some reason. But if we had S orbital, okay, alright, remember that L is equal to 0, and then PL is equal to 1, DL is equal to 2, and FL is equal to 3. So the form of the way it works is that the number of electrons in that subshell, okay, is equal to 2 times 2L plus 1. Okay, so you can also just see here how many electrons you may think it has. But I feel like this is just a better use, because based on this, from what we know about Krypton, its D, its S, and its p orbital are filled. So we have, let's start with the s orbital, right? L is equal to 0, so we have 2 electrons only, because 2 times 2 is just going to be 0. I mean, 2 times 0 is just going to be 0. Okay, so it's going to be 0 plus 1, which is still with just 1, and then times 2, that's how you get 2. Now for the p orbital or subshell, we have now 1, so 2 times 1 is going to be 2, plus 1 equals 3, so it's going to be plus 6. And now for the number of electrons for Krypton, okay, it's going to be now same thing. 2 times 2 is 4, plus 1 is equal to 5, times 2 is equal to 10. So the number of electrons, valence electrons in Krypton actually will be 18 valence electrons. Okay, so that is what we have there for the number of valence electrons. Okay, I think they may have mistaken the question, because there are 36 electrons in total for Krypton, but for valence electrons, which is just in the outer shell, ooh, actually even I got it wrong as well. It'll actually just be 8. Why? Because actually this right here, that d orbital, okay, counts in the previous orbital because of the 3. So really there's only this 4s2, 4p6. So Krypton on its most outer shell is just the 4s, right? Meaning that we don't even have this plus 10. It'd just be 8 valence electrons. Sorry about that. So just exactly, that's why we actually did the notation here, because it actually shows us that this 3d10 is from the previous orbital. So with that being said, the valence electron is just going to be 4s2 4p6, which is 8. Okay, we don't use this because the d orbital is in the previous one and there's no f orbital. Okay, let's see what they did. Electron configuration. Since the electron configuration, it is exactly IR. That is exactly what we have. 3d10. We determine the number of electrons in argon, which is 18, added to the number of the electrons in the last few subshells. So I think they missed what the point of the question is incorrect. They only want valence electrons, and that'll be the electrons in the outer shell, which is 8. Remember the whole octet rule and how noble gases prefer to just have 8 electrons. I mean, not noble gases prefer, but they do have 8 electrons in the outer shell, except for helium. It's because of this, actually, because you'll see that when you get to the p level, the S and the P, you will see that exactly it's usually in the most outer shell. So yeah, that is why it has 8 valence electrons. And yeah, let's move on to the next question, question 11. So I'm gonna take a quick water break